Welcome to Academic Guru's Tutoring Tuesday, where we answer all of your high school, college, and university questions. If you would like your question to be featured on next week's Tutoring Tuesday, please submit your questions to questions@academicgurusinc.com. Don't forget to subscribe so you can stay current with all of our new videos. In today's session, I'll be solving a stoichiometry question that was sent in by Kevin. And we've been presented with a reaction here. We've got 4 moles of ammonia that has been added to 6 moles of nitric oxide, and that yields 5 moles of nitrogen gas and 6 moles of water. And then the question reads, how many moles of each reactant were there if 15.2 moles of nitrogen gas is produced? I'm assuming here that you have a basic understanding of what is meant by moles, but the first thing that should jump out at you is the word reactant. The question is asking you how many moles of each reactant. So the first thing you should do is to identify the reactants within the equation. So if we look back, we can see that there are 2 reactants. Our first reactant is ammonia, which has been added to nitric oxide. And by contrast, our products are nitrogen gas and water. Now that we've identified what the reactants are and what the products are, our next step requires that we use the molar ratio to determine how many moles of each of the reactants were present in order to produce the 15.2 moles of nitrogen gas. So let's start off with the first reactant, ammonia. We'll try to find out how many moles of ammonia were present in order for 15.2 moles of nitrogen gas to be produced. Let's start off with the 15.2 moles of nitrogen gas, and we'll use the molar ratio between ammonia and nitrogen gas to determine how many moles of ammonia were initially present. From the reaction, we know that for every 4 moles of ammonia, there are 5 moles of nitrogen gas. So therefore, by multiplying 15.2 moles of nitrogen gas by 4 moles of ammonia divided by 5 moles of nitrogen gas, we find that 12.16 moles of ammonia were initially present. Notice that I placed ammonia in the numerator rather than the denominator because that is what we're ultimately trying to find. Now we can apply the same method to the second reactant, nitric oxide. Again, we'll start off with 15.2 moles of nitrogen gas, and we'll use the molar ratio between nitric oxide and nitrogen gas. So we have 6 moles of nitric oxide for every 5 moles of nitrogen gas. And after multiplying 15.2 by 6 and then dividing it by 5 moles, we find that 18.24 moles of nitric oxide were initially present. So if 15.2 moles of nitrogen gas were produced in the reaction, it must be true then that there were 12.16 moles of ammonia and 18.24 moles of nitric oxide initially present. So there you are, Kevin. I hope you found this helpful. Thank you for tuning into our Tutoring Tuesday channel. If you enjoyed watching this video and found it helpful, please give us a thumbs up, comment, and subscribe. We would love to hear from you. Until next week's Tutoring Tuesday, happy studying.